We've been working our way up in degrees of complexity. We started at the microcosmic level with line, then shape, then a single object, then several. Then we turned shape into volume and drew multiple volumetric objects considering aggregate shape and object-ground relations. Finally, we learned about positive and negative shape. These last ideas took us well beyond drawing isolated objects and gave us a more sophisticated idea about how the parts of a drawing relate. Though we didn't name it, we were really starting to talk about composition. Composition's nothing more than organizing. It's about organizing parts in a coherent whole. The Italian word disegnare means both to draw and to design, and the two are intimately connected. In 1890, in a work titled The Definition of Neo-Traditionalism, the French artist Maurice Denis wrote, "We should remember that a picture, before being a war horse, a nude woman, or telling some other story, is essentially a flat surface covered with colors arranged in a particular order." He's saying, sure, you see a war horse or a nude woman, but artists can't just think about horses and nudes. Artists have to consider the abstract stuff, the formal elements, line, shape, volume, and color, and how they're organized. In this lecture, we'll talk about the underlying structures of rectangles, because that's the shape of most of the drawings we make. Artists refer to this as the armature. For this lecture, you'll need pencils, eraser, a ruler, your T-square, triangle, compass, and a sheet of 18 by 24-inch paper. Most drawings have a shape, generally a rectangle, and it's made of constituent shapes that relate to that rectangle. And that follows from what we learned about aggregate shape and negative shape. Drawings benefit when all the internal shapes have a relationship with the shape of the drawing itself. These relationships have a fair amount to do with geometry because our starting point, a rectangle, well, it's a geometric shape. Even if we're drawing figures like Akins or Diebenkorn, we have to make sense of them in terms of the abstract geometry of the rectangle. You can see how both are organized in relation to halves, quarters, diagonals, and other significant measures of the rectangle. And we'll see in coming lectures how artists across a great swath of history, culture, and artistic convention have routinely composed in just this way. Many of the great artists of the Renaissance, like Leonardo and Dürer, were fascinated by abstract geometry and its application to drawing. In fact, you could say that drawing's very nature is abstract. The English word abstract comes from the Latin, abstrahere. Abs is a preposition meaning from. Trahere is a verb that has several meanings, including to draw. Abstrahere, or to abstract, is literally to draw out from. If you've studied a Romance language, you'll likely note that trahere looks an awful lot like a verb, an infinitive. If we have a root, tra, and then a Romance verb termination, ere, E-R-E. The root, tra, T-R-A-H, survives in modern Italian. Tratto means line, and ritratto means portrait. And there's a connection between tra and draw, both four letters with the same two central letters, R and A. And they sound alike, tra, draw. Both first letters, T and D, are sister sounds. We make them very similarly. Try it. T, d. For t, the tongue's slightly more forward when it hits the roof of the mouth. In phonetics, they're both called alveolars. Means the tip of the tongue flicks against the alveolar ridge. That would be the gums just behind the teeth. Similarly, the final letters of tra and draw, H and W, are also related. Again, give it a try. H. These are referred to as approximants. Both demonstrate smooth airflow. So, taking our root and swapping out T for D and H for W, well, tra is draw. In English, to abstract retains its abstrahere meaning of to draw out from. An abstract of an article refers to the main idea or ideas drawn out from the article as a whole. A track, like one you might run on, is like a line drawn on the earth. A related word, tract, as in a tract of land, is a piece of land that's been abstracted or drawn out and set apart from all the surrounding land. That tract itself could be created with a tractor. In this sense, a tractor is just a big drawing tool. And artists have indeed drawn with tractors and similar tools. marking the surface of the Earth at a large scale. You may have seen images of James Turrell's Rodin Crater, or works like this one, Spiral Jetty by Robert Smithson. Many people, when they hear the word abstract, immediately think about a kind of art, Jackson Pollock or William de Kooning. And of course, abstraction does have this meaning too. But here, we're not talking about a kind of art, but about concepts that apply to all kinds of art. Both Akins and Diepenkorn are abstracting. They're pulling out a particular rectangle's worth of visual event, and they're organizing it relative to a given rectangle, the drawing's shape. And as you've done, they're using abstract shapes to draw with, to create large ground shapes, aggregate shapes, and as building blocks to construct the things in their drawing. So, our challenge, to paraphrase Maurice Denis, is to arrange things on a flat surface, generally a rectangle, in an order that makes visual sense. Every rectangle, even before we make a mark on it, has a latent visual structure buried just beneath the surface. And this structure affects the way our eyes traverse the blank page. Take a piece of paper and put two dots on it. Your eyes go back and forth between them. We're drawn to connect them on a linear path. If I add a third dot, you'll likely connect them as a shape, here a triangle. And it's just what many ancient peoples did looking up at the night sky. They saw points of light, stars, and connected them, seeing lines and shapes. That's our operating system at work. We're wired to connect the dots, and this has direct bearing on composition. Let's get into this a bit. Put a sheet of paper on your drawing board in the landscape position. Then draw a rectangle that's 9 by 12 inches in the center of your page. Take a hard look at your rectangle. Are there any points to connect? Is there a line implied by the rectangle itself? You're probably getting the idea. You could connect the corners with a diagonal. The way our eyes react to the rectangle's corners is similar to the way they react to two random dots on a page, or stars in the night sky. Our eyes will move automatically from corner to corner on an otherwise blank page. Our next implicit line is the other diagonal, so draw that too. The intersection of these two lines has created a new point, the center of the rectangle. It's an important and strategic location. While it doesn't give us 2 points to connect, it does suggest two more lines. The first, a horizontal through the center point. The second, a vertical through the same point. These two lines, in a way, echo or rhyme with the four lines of the rectangle itself. The central horizontal echoes the top and the bottom, the central vertical, the right and the left sides. Now your choices really open up. So many potential points to connect. Let's start with four diagonals, the diagonals of the vertical halves. These create two large intersecting triangles. Each one's flanked by a set of right triangles pointing in opposite directions. It also creates a symmetrical diamond pattern reminiscent of the Blombos Cave etched piece of ochre. Let's add another four diagonals, those of the horizontal halves. And a final set, the diagonals of the four quadrants. These create a large diamond in the rectangle. Artists refer to this as the rectangle's armature. Some artists envision a more scaled-back version, others a more complex version. We'll be adding a couple more layers of complexity, but just as it is, I find this figure fascinating to look at. While ostensibly flat, it also begins to appear three-dimensional, like a faceted transparent crystal or diamond. It's worth noting, we really didn't invent anything here. We're just listening to the rectangle, doing its bidding. Not only is this figure distilled from the rectangle, but it gives us a lot of information about the rectangle. Notice these points of intersection. They're intersections of the diagonals of the vertical and horizontal halves. They indicate our vertical and horizontal quarters. Let's draw those in. The rectangle now has two underlying grids. We already had a grid giving us the rectangle's quadrants. We now have an additional grid on the quarter. We've divided the rectangle into 16 equal sub-rectangles, 4 columns and 4 rows. There's a fractal quality to this. There are a couple more interesting points of intersection. There's the three-way intersection of the diagonals of the rectangle, the diagonal of the vertical half, and the diagonal of the horizontal half. This reveals the rectangle's vertical and horizontal thirds. So let's add these in too. This gives us a grid of thirds. Here's another. All the two-line intersections of the diagonals of the vertical and horizontal halves. These reveal the rectangle's horizontal and vertical fifths. Let's add this grid too. We now have 4 layered grids, a 2x2 with 4 units, a 3x3 with 9 units, a 4x4 with 16, and a 5x5 with 25. Altogether, we get this. There's a clear correlation with music here, in particular rhythm. We can think about the page like a musical measure. It could be left empty, divided in 2, in 3, 4, or 5, and in many other ways that compound on these simple divisions. As in music, we could juxtapose these divisions, creating complex visual polyrhythms. The Mandarin word hua means painting or drawing. The modern character looks like this. It depicts a rectangle, framed inside a rectangle, with divisions at the horizontal and vertical halves. There are also stresses at about the quarters. In many ways, this character is like the horizontal and vertical aspects of the armature we constructed, and a blueprint for a common compositional strategy. That Chinese has such a wonderfully distilled character like hua isn't wholly surprising. An attribute of good Chinese handwriting is that the strokes for each character balance within an imaginary square. Whether the character consists of 3 or 30 strokes, the strokes have to relate to that square. When learning to write Chinese, students practice their characters within a square grid. There are several types, but a very common one looks like this. Familiar, isn't it? As we've discussed, written Chinese is a pictorial-based language. How do you practice making pictures? Well, it's a good idea to do it in relationship to the major stresses or armature of the rectangle. Those would be the horizontal, vertical, and diagonal halves. When you look at Chinese characters, you can see how they're organized around the major stresses or major thoroughfares in the rectangle. Some characters are quite simple and symmetrical, while others are quite complex and asymmetrical. But the characters, little drawings really, are composed in relationship to that imagined rectangle and its armature. Coming back to our rectangle, it's worth noting that all we did was follow some simple procedures, a game of connect the dots. And we've learned a lot about our rectangle's measures, halves, thirds, quarters, fifths, and we did all this without a ruler. We could go on like this infinitely. We now have scores of points that could be connected. We also have all the new rectangles in our 4 sets of grids. That would be 54 rectangles. Each one of these has all the same relationships that we found in our primary rectangle. So if we could draw small enough lines, this could proceed fractally and infinitely. And you might want to take this further to see what kinds of relationships you can bring out. There's a great deal of complexity in all this. I find I can stare at these figures for a long time. All kinds of interesting visual meanings emerge. I can read lines and flat shapes on the surface, or I can read darker lines as coming forward in space and lighter ones moving behind, receding into the distance. I can read the lines as constructing planes twisting in space, as well as 3D crystalline structures. One of the ways I've come to think about the armature is that it reveals that not all paths through the rectangle are equal. There are the equivalent of 8-lane superhighways, 4-lane local roads, humble dirt trails, and open fields. Developing a sense of the rhythm of the landscape of the page is central to composing well. Now, I'm not claiming that all artists have drawn armatures in their rectangles. Some fine artists develop a feel for composing by looking at other artists' work, paying close attention to the compositional strategies that are deployed. And we'll be doing this too. But drawing the armature in a range of different rectangles is useful, especially if you pay attention to the shapes and relationships that emerge as you add each new line. It's a great way to develop a sensitivity to the underlying structure of the format shape. The essential character of every rectangle is defined by the relationship of its verticality to its horizontality. That relationship can be expressed by a ratio. A rectangle with a 1:1 ratio, it's a square, feels very solid and stable. A rectangle with a ratio of 1:2 feels different, expansive, panoramic. Simply rotating this shape so that it's now 2:1 produces a rectangle that feels much less stable than either the square or the 1:2 rectangle. No doubt this has to do with the way we experience gravity. The rectangle you just drew is 9 by 12 inches, a 3:4 ratio. A next step is to experiment with different ones. Try a 1:3, a 1:4, a 2:3, and a 2:5, and then rotate them 90 degrees. Note how they feel in their portrait orientation. Getting to know rectangles like playing scales and arpeggios for a musician. You begin to develop a feel for the terrain and the measure among the intervals. There's one rectangle you've likely heard of, the golden rectangle. It's based on the golden ratio, also known as the extreme and mean ratio, the golden section, the golden mean, and the divine proportion. It's had a long history. The idea that there are certain ratios or proportions that are beautiful or harmonious goes back at least 2,500 years to the Greek mathematician and philosopher Pythagoras. A couple hundred years later, his countryman and fellow mathematician Euclid was among the first to define the golden ratio. Now, you'll remember, many of the Renaissance heavyweights were enamored of geometry, and both Pythagoras and Euclid are thought by some art historians to be among the figures in Raphael's school of Athens. Some scholars identify the figure wielding the compass as Euclid. Pythagoras and Euclid's ideas about measure and proportion would turn out to be very important to 15th century Italians like Raphael and his contemporaries. Many ideas about ideal proportions made their way to 15th century Italy via the 1st century BCE Roman architect and writer Vitruvius. He authored De Architectura, translated as the 10 Books of Architecture. In it, he wrote about many things, including pulleys, water clocks, and surveying instruments. But he also coined what have come to be known as the Vitruvian virtues. He describes how a structure should be utilitas, firmitas, and venustas, utilitarian, solid, and beautiful. He related this last virtue, beauty, to proportion. And he applied this not only to architecture, but also to the human figure. 1,400 years later, Leonardo da Vinci would pick up on this and make his famous drawing based on Vitruvius' ideals of measure and beauty. It's no accident that Leonardo became familiar with Vitruvius. His writings were rediscovered in Florence in the early 1400s and deeply influenced a number of Italians of the period. Notable among them was Leon Battista Alberti, who wrote his own book on architecture modeled on Vitruvius, De Re Edificatoria, On the Art of Building. Alberti also wrote a seminal treatise on painting titled De Pictura. We'll speak about that book when we delve into proportion. Alberti's contemporary, Luca Pacioli, was a friar, a mathematician, and one of the first to develop systems of accounting, a true Renaissance man. He wrote a text called Di Divina Proporzione, the Divine Proportion. This text concerned itself with artistic proportion and the golden ratio in particular. Both he and Leonardo at the time were enjoying the patronage of Ludovico Sforza, the Duke of Milan, and Pacioli asked Leonardo to illustrate his text, and the two collaborated on the project. Many people have studied the golden section in significant architectural and artistic works, from the Parthenon in Athens to Hagia Sophia in Istanbul, from Leonardo's Mona Lisa to Mondrian's abstract paintings. And there's some consensus among scholars and some disagreement about how much artists have indeed relied on it. There's even a paper written in 2008 titled Golden Section and the Art of Painting by a Romanian scientist, Agata Alario. In it, he claims to have measured and tabulated the ratios of the rectangles of 565 paintings by Caravaggio, Cézanne, Delacroix, Goya, Rembrandt, Van Gogh, and others. He reports that the average rectangle used by these artists was far from a golden ratio rectangle. In fact, he reports that very few of the rectangles used by the artists in his sample were golden. In any case, it's so famous that I'd be remiss if I didn't explain how to construct it. And I'll leave you to decide for yourself if it's in any way special. Let's start with that ratio, Euclid's ratio. The basic idea is this. We have a line segment made of two constituent line segments of unequal length. And here's the key. The ratio of the shorter line segment to the longer line segment must be the same as the ratio of the longer line segment to the entire line segment. I know that's a bit dense, so let me repeat it. The ratio of the shorter line segment to the longer line segment must be the same as the ratio of the longer line segment to the entire line segment. To do this, make a line segment. Using the segment as a base, draw a square. From the center of the base, draw a diagonal to the upper corner of the square. Here we've gone to the right. Now, take a compass and put the point on the center of the base and draw a portion of a circle from the upper corner of the square to a point where it would intersect with the base. Then extend your base to intersect with your circle. The ratio of your two line segments is now a golden ratio. The ratio itself is 1.618, and it's represented by the Greek letter phi. This is in honor of the 5th century BCE sculptor and architect Phidias, who's thought by some to have used it in his Parthenon statues. Now, onto our golden rectangle. We'll retain the height of the square and construct a new rectangle on the golden ratio base. That's it. So this is our 1.618 rectangle, meaning the height is 1 to a width of 1.618. What makes this rectangle special? We want to keep Maurice Denis' idea about composition in mind. Things have to be, quote, arranged in a particular order, unquote. And this may sound a bit odd, but we're trying to find an organizing principle for the relationship of the vertical to the horizontal aspect of the rectangle. That relationship defines the rectangle. We want them to relate. We want them to feel like they belong together. A jacket and a pair of pants are clearly different things, but we can make them relate, make them feel like they belong together when we literally make them from the same cloth. We get a suit. The vertical and horizontal could be identical twins. That's a very strong relationship. It produces a square. But some might say squares are too predictable, not interesting enough. So we could design a rectangle where one measure was clearly related to the other measure, but not identical. For instance, one side could be a given length and the other could be 1 1/2 times as long, or 1 1/4 times as long, which, incidentally, according to the Romanian scientist, is the most popular ratio for rectangles used by the artists he sampled. Over 400 of the 568 rectangles exhibited ratios around 1 to 1.25. That would look like this. In the golden rectangle, there's a real relationship, but it's somewhat complex. The height, B's relationship to the overall width, C, is the same as A's relationship to the height B. And A is the remainder if we subtract the height B from the total width C. So they're intimately connected. Here's the math. A divided by B, which is 0.618 divided by 1, is equal to B divided by C, or 1 divided by 1.618. The quotients are identical, 0.618. Put more succinctly, A is to B as B is to C. Another permutation is the root rectangle. It's constructed similarly to the golden rectangle, but instead of drawing the diagonal from the center point of the base of the square, we draw it from one of the lower corners. Let's try it. Draw a square. From the lower left corner, draw a diagonal to the upper right corner. Place the compass point on the lower corner and draw a portion of a circle from the upper corner of the square to a point where it would intersect the base. Extend the base to intersect the curve. Retain the height of the square and construct a new rectangle on the longer base. That's a root 2 rectangle. Repeat this procedure on the new rectangle to produce a root 3 rectangle, and repeat it again for a root 4 rectangle. Now, if you're interested in making circular drawings, we call them tondos, or elliptically shaped drawings, the same ideas can apply. As we've noted, the circle has a strong relationship with the square, and many of the square's stresses can be used on the circle. Each ellipse also fits neatly into a specific rectangle, and likewise that rectangle's armature will be useful in discovering the ellipse. And many of the rectangular structures we've discovered in the rectangle can be turned into curvilinear structures to rhyme with the outer edges of the circle or ellipse. And these curving lines can even be used in a rectangle. If you're interested in other shape drawings, regular or irregular, the same idea holds. Understand the internal structure of the format shape and relate the divisions and shapes in the interior to the whole. Earlier I'd said that a good way to develop a feeling for composing is to draw basic geometric divisions into a range of different rectangles. This will acquaint you with their underlying structures. I also mentioned that it's very useful to pay close attention to what emerges as you add each new line. Let's return to where we started today, to that single diagonal crossing the page. Even something this simple will reward our attention. By making that one line, I've actually accomplished quite a lot. I've divided my rectangle in half. I've created two shapes, two triangles. I've created contrast. I've created a new direction, diagonal. That contrasts with the format itself, which is made up of two vertical and two horizontal lines. I've created asymmetry where earlier there'd only been symmetry. And while you may read it as flat, as two right triangles, there's a lot more to it. I've actually begun to create an object-ground relationship and the illusion of three-dimensional space. Add a tree and a stump, and it's a sloping hill. Add a couple more humble marks, and we see the ocean and the sun and the clouds above. In this case, the lower triangle is forward in space, and the upper triangle represents the space behind it. This is an object-ground relationship with the lower triangle as object and the upper is ground. But I could flip that space. If I double the diagonal and add a couple objects, I have a still life on a table with the floor below it. Now, the upper triangle is object, the lower one ground. We could also interpret the single line as a drawing of a cardboard box seen at an angle, or a pitched roof seen from above, or a wall meeting a floor. Coming back to the diagonal itself, if it were a hill, it's one with a relatively gently sloping rise, about 37 degrees. We could hike up to the top without too much trouble. And if we chose to ski down, well, wouldn't test our skill, it's a beginner's slope. But turn your piece of paper to the portrait position, and now that slope's over 50 degrees. Walking up would be a real hike, and skiing down, well, you'd want to be sure you knew what you were doing. And that translates to drawing. The greater the slope, the greater the sense of activity and instability. Let's add that second diagonal. We've now created four shapes, triangles. We've restored balance and symmetry. And we have a new illusion of three-dimensional space. We could be looking down at a four-sided pyramid. Or we could be lying on our backs inside the pyramid, staring up at the ceiling. Equally, we could be looking into a deep room or tunnel. And this relates directly to Frank Stella's mitered squares, which we looked at briefly in an earlier lecture. Try looking at the left rectangle and seeing it as a deep room. Simultaneously, try to see the right panel as a pyramid viewed from above, then switch. Then try and see them as two rooms, then two pyramids from above. Maze-like, no? Coming back to lines, one way to think about drawing, line drawing, is that what we're really trying to do with every line we make is to transform the white of the page from something inert and flat to something that creates some illusion of three-dimensional space. So it's a good idea to stare at the lines you draw and ask yourself how they're changing the white of the paper, or a portion of it, making it bulge or dip, or shift into an oblique plane orientation. You'll note that all the lines we've drawn in this lecture fall into one of three categories: horizontal, vertical, or diagonal. Our feelings about these directions in drawings parallel our experience of them in everyday life. And this likely goes back to our very first ancestors. Imagine a young Homo sapien. He's walking along and comes upon a sleeping Neanderthal. The Neanderthal's got his club lying beside him, all horizontal. That's not a big deal. But if the Neanderthal were standing vertical with his club held up vertically, well, you can imagine the youth would pay a lot more attention to that. And if that Neanderthal were lunging with his club, everything all diagonal, the early Homo sapien who didn't pay a lot of attention had a very low probability of passing on his genes. Probably not one of our ancestors. Horizontals are like a calm sea. Verticals, less so, but nothing like diagonals, which are active, unstable, and grab our attention. And the greater the pitch, the greater the feeling of action and instability.